So the next our panelist will be Durst and Schrunk. Will you please take the stage? You have 5 more minutes. Thank you.
Okay. Aloha. Good morning from Waimea, Hawaii. My name is Steve Durst, Director of the International Lunar Observatory Association. And our paper this morning is Malapert Mountain, a strong candidate site for CLPS moon missions with optimal observation, communication, and power conditions, as depicted on the artwork by Michael Carroll on screen. The paper will be presented by my longtime associate, Dr. David Schrunk, MD, who's the author of a book, The Moon, all 400 pages of it, and a longtime advocate of Malapert Mountain as the ideal gateway to the moon and beyond. Dr. Schrunk.
Good morning. I have several slides, so we'll need to go fairly quickly. We have the next slide, please. This is the proposed CLPS mission to Malapert Summit. Next slide. Malapert Mountain has a mission for 100 days duration, but that's at the lower end of the estimation. It may be as long as 200 days duration mission using solar power, long periods of sunlight. Next slide. Objectives are communication links between the Earth and the lunar South Pole, Earth observation, astronomy, and lunar surface imagery. Next slide. And Malapert Mountain is at 0 degrees longitude, 86 degrees south latitude, 5,000 meter elevation. Next slide. This is a map of the South Pole showing that Shackleton, Malapert, and the Earth are on the same line of 0 longitude. That fortuitous location for Malapert and Shackleton. Next slide. This is a blow-up of the summit of Malapert. In the center, you see a small crater about 1.2 kilometers in diameter. Landing sites that have been selected are below and to the right of that image, just below and to the right. Next slide. Advantages of Malapert are long periods of sunlight availability, Earth visibility, and a view to the South Pole. Next slide. This is the iconic image from the Japanese spacecraft showing Shackleton and Malapert, the direct line of sight. You can see that sunlight is striking the south face of Malapert. And of course, you can see the Earth in the background. So this is the geometry that's favorable for placing instruments at Malapert. Next slide. The summit area receives sunlight.
1 more minute.
And you have a summer and a winter, as it were. We can plan on a 100-day mission minimum, and for the summer season, that mission duration may be as long as 200 days with a few hours of blackout, or without sunlight, rather. Next slide. This is a study done by Busi et al. The red dot areas show areas of increased sunlight availability. The South Pole receives sunlight 80 to 90% of the time at the rim. You can see 2 points at the top of the screen. Those are at Malapert, where we are going. Next slide. There's a possibility of real-time Earth to Malapert to Shackleton communication based upon studies that we have performed. Next study, or sorry, next slide. From Malapert, this is a cross-section of the topography. From Malapert, you can look down to Shackleton crater illustrated there, and to the left, you can go back to the Earth. Next slide. And this would allow people or controllers on the Earth, next slide, to communicate to Malapert on the right, and from there to rovers in the South Polar region. Next slide. This is that same illustration by Busi, but with lines drawn to show that from Malapert, you could have communication links and control links to areas throughout the South Polar region, useful for directing resource recovery, such as water deposits in the cold trap areas. Next slide. Science objectives, we're going to do Earth observation. Next slide. We'll have a continuous observation of the Earth. Next slide. For studying weather, lightning, climate, and Earth-Moon dynamics. Next slide. Astronomy, we'll have the entire southern hemisphere for observation, Milky Way, and planets. Next slide. There's an opportunity for long exposures along the long axis of rotation of the moon. And next slide. That's the one I just described. Next slide. Next slide, please. This is the future of the moon with placement of telescopes all over the surface of the moon. At the top, you can see this would be Malapert. And along the long axis of the moon, we can take observations of long duration, maybe weeks or months or even years of a telescope dedicated to gathering light from a single object. So we would demonstrate that at Malapert. Next slide. We'll do lunar surface topography studies in the Malapert area and the South Polar region. Next slide. These are the requirements for the lander, solar power navigation, telescope, and so on. Next slide.
We need you to wrap it up, please.
Summary. This is the fortuitous confluence of advantages at Malapert, a very valuable point. Next slide. Eclipse mission will achieve multiple science objectives. Next slide. And we expect that it will demonstrate that Malapert is a key location for the next stages of lunar exploration and development. Next slide. That's all. Thank you very much.
Right. Thank you very much.